This conference will now be recorded.
Good morning, everybody. You will see the Unit 5 from today onwards. So, renewable energy systems means we are going to study about what are all the various types of renewable energy systems available, their operation, application, advantages, so all that. So, the order of the units is like in the first unit, you will be seeing about the introduction of renewable energy systems, and in the second unit, we saw about wind energy, which is the very big reliable renewable energy source. And the third unit we saw about what is solar power. Solar power is also a reliable renewable energy source, which is having a large application in the country. And in the fourth unit we saw about very small topics like biomass, geothermal energy, and hydropower. So these power plants have some limited applications only. They do not have large, massive power production units. And in the fifth unit, we are going to see what are the other types of renewable energy sources available. So these are there are some small units of renewable energy sources from which we will be able to generate power. The first is tidal energy. So under this, we are going to study how to extract energy from tides. Then we are going to see the types, that is barrage and non-barrage type of tidal power systems. Then we are going to see about wave energy. Right. First of all, tidal energy is different and wave energy is different. Okay. So of course, both the energies collectively, we are going to take it from ocean. If at all we have a river, or if at all we have some small pond, we'll have some small waves, we'll have some small tidal tides, from which we'll be able to extract energy. So that two types of energy is called as tidal energy and wave energy. And towards the next topic, we'll be seeing about what is the ocean thermal energy conversion system, that is how to extract heat energy from oceans. Right? For example, you have a very big beach or a very big sea. So how to take uh, thermal energy from that particular river or ocean. So that we'll be studying about in topic of ocean thermal energy conversion systems. Then hydrogen production and storage. Right? So tide is a natural process, wave is a natural process, ocean is also a natural process. Hydrogen is also a naturally available component. Hydrogen is present in water, right? But the only thing is we'll have to separate hydrogen from water separately, right? We'll do some electrolysis process and we'll separate hydrogen and we'll extract the hydrogen energy and we will use that for our operation in the terms of fuel cell or in the terms of storage units, right? So under this we are going to see about mainly about hydrogen cells based upon fuel cell operation, right? So we know what is fuel cell. Fuel cell is one which is going to store energy basically. So for the operation of the fuel cell, we require hydrogen storage units, and to this fuel cell, we feed the hydrogen, and this hydrogen extracts the power. Right. So under this, we are going to study about what's the principle of working, what are all the various types, and we are going to see about the construction and its applications. And also, we're going to see about what is the energy storage system based upon hydrogen. And in general, we are going to see what is hybrid energy systems. Right? So this part, energy storage system and hybrid energy systems, both are not relevant directly to the topic, but energy storage systems are a part of renewable energy system. Because first of all, what is renewable energy system? It's energy storage system. So energy storage system is one in which we are going to store the energy, and we can take back the energy when the supply is not available. So energy storage system is very important for renewable energy system. For example, if you take wind or if you take solar power, so if you take wind, there is wind availability in a particular place in a tremendous way for a small period of time. That is, the wind will not be constant throughout the day. Right? Similarly, sunlight also will not be constant throughout the day. The level of sunlight and the power extracted by the solar panel will change depending upon the time, depending upon the climate, all that. So whenever we have enormous amount of energy, we store that in a battery. And whenever we have very less amount of energy, especially during night time in case of solar PV cells, we will be able to operate the system with respect to a battery. So this battery will help you to feed the power to the solar PV system. Similarly, in the wind power, sometimes the wind will be very high, sometimes the wind will be very low. During low weather, low wind conditions, we will be able to operate the battery and we will be feeding the remaining part. Right? And always remember, even if your generating unit is not constant, your load is constant. Right? Your load is always constant. Your generating unit may or may not be constant, but your load will always demand a constant voltage. So this constant voltage and current will be given only by the addition of energy storage system. So what is hybrid energy system? Hybrid is again the combination of more than one type of renewable energy source. It's called as hybrid energy system. Now, why do we go for hybrid system? Because it is intermittent. If you take solar, solar is not continuous. If you take wind, wind is not continuous. So, but we want a constant output at the end of the day. So, what we do, we combine this both. So, whenever we have a solar, in that instant, if we do not have a wind power, then the solar power will feed the system. So, whenever we have the wind power and we do not have the solar, then the wind power will have to feed the system. So, hybrid energy systems are very important to maintain consistent output to feed the load. Right? So this is about the introduction of the units. So we'll start with the basic introduction of what we are going to see in this unit. So first is tidal power. Tidal power and tidal is the form of hydropower that converts the energy obtained from the tides into useful forms of power. Okay? First of all, what is tides? Okay? Tides are produced in the ocean, okay? Because of the movement of the earth and the flow of the air. Tides are produced in the ocean. Okay, so these tides we are using to run a turbine. Okay, so these tides will be produced in the ocean and they will be installed in the ocean. Okay, the turbine will be installed in the ocean, and these tides, when they hit the turbines, they start to rotate. Okay, and this will be coupled to a generator and will generate power. Okay, very simple of operation. Next is wave energy. Wave energy is very similar to tidal power, but wave energy is different. Okay? Wave energy is very similar to tidal power, but wave energy is slightly different from tidal power. Like wave energy is the uh, transmitter. Okay? Wave is a transmitter of the tidal wave. Okay? So it is like a wind. Okay? Wave is like a wind. Again here we connect a turbine and we rotate the turbine and we couple the turbine to a generator. So the energy captured is then used for all different kinds of useful work, including electricity generation, water desalination, pumping of water. So the output is mechanical energy. This mechanical energy can be used for any purpose. Either you can use it for operating a generator and converting that mechanical energy into electrical energy, or you can use it for water desalination, that is purification, and also you can use it for pumping the water. Okay? So usually, initially, windmills were used for pumping the water. Right? So now, if at all you have a mechanical energy, you can use it for pumping the water at any application. In that case. So next is motion thermal energy conversion system. It's a process that can produce electricity by using the temperature difference between deep and cold ocean water and warm surface waters. So this I can tell you, like if at all you see this Reliance power plant, there are many types of many Reliance power plants installed in Krishna Godavari districts of Andhra Pradesh, right? So they will extract gas from the river as well as this gas is extracted by the difference in the temperature. Right? So that is called as motion thermal energy conversion system. So Reliance is operating with that particular project. Right? So in Tamil Nadu, we do not have any Reliance project, but in Andhra Pradesh, especially in Krishna Godavari rivers, this project is very famous. Okay? A fuel cell works by passive hydrogen to the anode of a fuel cell and oxygen through the cathode. At the anode side, the hydrogen molecule are split into electrons and protons. So what is fuel cell? Fuel cell is that which is used for storing the energy. So what is the fuel? The fuel is basically hydrogen, right? Now this hydrogen will store the energy and this will dissipate the energy in the form of anode and cathode, right? So we'll see the operation of this fuel cell in this chapter. And we'll see the last topic as hybrid energy system. Hybrid energy system usually consists of two or more renewable sources used for together to provide increased system efficiency as well as create balance in energy supply. So hybrid energy will be having mostly two types of sources, more than two types of sources, either wind or solar or wind or biomass, anything like that. And this is basically used for maintaining the continuity of supply. Right? So even if one source fails, the other source will feed the power continuously to the load. So we'll enter into the first topic, that is what is tidal energy. Tidal power, also called as tidal energy, is any form of renewable energy which tidal action in the ocean is converted into electrical power. Right? So basically, we are going to utilize the tides. Okay, so why this is called as renewable energy? Why tidal energy is called as renewable energy? Because ocean is a naturally created component. Okay, ocean is a naturally created component in which tides are also natural. But all you have a ocean, obviously tides is possible. Okay, just like you can imagine a beach. Okay, if at all beach is a natural component, the beach will have tides. Okay, tides is a natural process. If you have a beach, there will surely be tides. So these tides we are going to utilize for converting the power. Okay, so this is called as the tidal energy conversion system. So basically, there are three main types of energy that can be captured from the ocean. One is wave energy, another one is tidal stream, and one is tidal range. Okay, so these are three types of ocean energy thermal systems. Right? Next, using the power of the tides, we produce. Okay, this is important. How this tides are produced? Okay, how these tides are produced? Okay, it's very simple. You just assume you have a beach, and in the beach there are uh, tides. Okay, now what determines this tides? Okay, some tides will be very heavy, some tides will be very small, some tides may not be reaching the shore at all, right? So who is producing these tides, or what is the principle of production behind these tides? Is that tides are basically produced because of the gravitational pull both from the sun as well as the moon. Okay? Especially moon plays a very big role in the production of tides. Right? Moon is the main factor which will produce tides because the gravitational force acting upon the moon is very high. Right? So moon will try to pull all the water, but it will not be able to pull. So what will happen? The earth will pull all the water again. So this pulling and force between the earth and the moon will cause the tides. Right? Because of this, we'll have lots of tides in the beach, basically. Now, if at all you see on a full moon day, they will tell that the tides are very high. Right? If at all it is a half moon day or no moon day, then the tides will be very less. Okay? So, which means tides have a direct impact on the moon condition also. Right? So this is how tides is produced. So this you must understand how tides are produced. Okay? Again, you cannot control the flow of tides. Right? So for example, you want suddenly increase the power. So you cannot increase the force of the tides. Right? So it's a natural process by which we cannot do anything to change the force of the tides. Now, next is the Earth's rotational and gravitational power pulls the water down and thus creating a high and low tides. Again, you see this how this uh, tides power is determined is the force of pulling of the earth on that particular area, right? So this gravitation pull of the earth also determine what is the level of force of the tides that we are going to extract. So in continuing, the tidal stream devices, so which utilize these currents are broadly similar to submerged wind turbines. Okay? Now, if at all you still do not get an idea of what is tidal energy system, then you can blindly assume a wind turbine. A wind turbine is placed on earth. Okay, the wind is impinging on the blades, and the wind turbine is starting to rotate, and we generate power. If you place the wind turbine on the beach inside the sea, okay, and these tides are hitting the wind turbine, automatically the blades will start to rotate, and this process is called as tidal energy conversion system. Okay, this is given just for simple understanding. Okay, how to understand ocean energy system. So this is common for wave energy also. Again, if you take wave energy, again we are going to utilize the waves in the place of tides for turning the turbine, right? So due to the higher density of water, and blades can be smaller and turn more slowly, but they still deliver a significant amount of power. Now these systems are not that much reliable. So that is the point which I would like to tell you. So tidal energy systems are systems which generate very low amount of power because there are lots of factors involved, capital costs involved, maintenance costs involved. So we do not invest large amount of money to generate huge amount of power from these systems. So to increase the flow and power output from the turbine, concentrators or chutes may be used around the blades to streamline the concentrated flow towards the rotor. Right. So the power output of the turbine or the concentrator may be used around the blades. That is, the blades construction change so that we will be able to increase the flow of water. Right? So this can be installed only along coastline. Coastline means around the border of the ocean. Right? So coastline often experience two high tides and two low tides on a daily basis. The difference in water level must be at least 5 meters, which is high to produce. That is, the tide's height must be at least 5 meters. Okay, it must be at least 5 meters to produce electricity. So next is barrage and non-barrage types of tidal bar systems. So basically, there are two types. One is barrage type, another one is a non-barrage type. So we will see what are the types and operation of barrage system and non-barrage system, and we will also see what are all the operating methodologies of this type of systems. Right? So basically, we have two types, that is barrage and non-barrage. The tidal barrage uses long walls, dams, sluice gates, and tidal locks to capture and store the potential energy of the ocean. This is like our hydel power, very close to our hydel power, except the penstock. Every system will be there in this particular barrage system. Barrage means it's a barricade, okay, like a barricade which we place for controlling the traffic. Okay. Barrage means it is a long wall built across the ocean to stop the water flow. Right? That is called as barrage. So the tidal barrage uses long walls, dams, sluice gates. So all these are used for storing the water, basically. So water has a large amount of potential energy. So this potential energy is being stored. Okay? And later on, we'll use this potential energy to run the turbine. Right? The tidal barrage is a type of tidal power generation scheme that involves the construction of a fairly low walled dam known as tidal barrage. Right? The bottom of this barrage dam is located on the sea floor. The top of the tidal barrage being just above the highest level that the water can get to at the highest annual tide. Right? So the barrage has a number of underwater tunnels cut into it. That is, to store the water, we bring the water through many pipes. Okay? Tunnels are huge pipes. Right? Sluice gates are controllers used in dams, basically. Sluice gates are basically controllers used in hydel power plants. Also, we have seen this topic. What is a sluice gate? The highest pressure valve is called as sluice gates. So fixed within these tunnel are huge tidal turbine generators. Okay, again we have a type of turbine that is called as tidal turbine. Okay, so that spins the seawater, pushes them either to fill or empty the tidal reservoir, thereby generating. Okay. So again here we are going to use a tidal turbine. So far we have seen about what is steam turbine, what is wind turbine, and here we are seeing about what is a tidal turbine. Tidal turbine is one in which we are going to impinge the tidal waves. Okay, that water, the force of water, we are going to impinge on the blades, and it will rotate the turbine, and this turbine will be coupled to a generator. So what are the three types of tidal barrage system? Basically, one is flood generation, other one is ebb generation, other one is two-way generation. So these are the three types of tidal power generation. So the tidal energy extracted from tides is a potential energy, and the tides moves in a vertically upward downward direction, and it has a low and a high tide. Also, a tidal barrage system exploits their head differential to generate electricity. That is their water level. Depending upon their water level, the total system's output will change. Right. So the three types are this. And one is flood generation. The tidal power is generated as the water enters a tidal reservoir on the incoming flood tide. Okay. Flood is nothing but a huge flow of water and calling as flood. So you may not assume flood as like any massive destroy like that. Flood is nothing but huge flow of water. Okay. Huge flow of water is called as flood. So why do I talk about flood? Because flood is caused when we have large amount of water. Usually in the ocean we have a very huge amount of water. So I talk about flood here. Okay. So the tidal power is generated as the water levels leaves the tidal reservoir. So we have a small ebb generation here. Then we have two-way generation point, that is as the water flows in both direction, that is inwards and outwards from the reservoir. So we have two-way power generation. So tidal barrage flood generation system. So we see what is this operation. I think I have the diagram. Yes. Okay. So the tidal barrage flood generation uses the energy of an incoming rising tide as it moves towards the land. Okay. So usually, if you assume a beach, the tide will be produced towards the center of the beach. Okay. And the tide will be coming from the center of the beach and it will reach the land. Okay. We used to stay in the land and it will come and hit us. Okay. Now, this is the general form of tidal production. Right. So as the tide turns and starts to come in, the sluice gates are closed and the barrage holds back the rising level, creating a difference in height between the levels of the water on either side of the barrage system. So what we are going to do, we are going to stop this water which is reaching the land, and this water will hit at the turbine at a very high force. Right? So we are going to operate the sluice gates to control the flow of the water, and thereby we will be able to generate power. Right? So this generates more kinetic energy to be flowing into the turbine. Okay. And next is the tidal reservoir is therefore filled up with the turbine tunnels, which spins the turbine generating tidal. You can see the pictorial diagram. So this is the diagram of a tidal barrage food generation system. So what we have here, we have a very big dam here. In this dam, we have a very big dam here. So this dam is calling as a tidal barrage, right? So this tidal barrage is called as very big dam. So which we are going to use for stopping this high tide water, right? So what are all the parts? First of all, we have two sluice gates. Okay? these two sluice gates are going to operate at a very high pressure, basically. Okay, they are very controllable gates, which is going to operate at a very high pressure. And this is the turbine which I was talking about. That is the tidal turbine. Right. Now, what is the operation? The operation is we have a beach here. So this is the beach. The beach is having some tides, and these tides are flowing this way. Suddenly, what we do, we stop this water and we narrow down the water to a very small area. Okay. Now, when the water is narrowed down to a very small area, it is hitting a turbine, and this turbine is starting to rotate. Okay. So this water is having a very high pressure up to this area. At this point, the pressure will be very, very high, and at this point, this pressure will be impinging on this blade, and this blade will start to rotate. And after the work is done, the water will come outside. Right? So this is the operation. So low pressure tide and high pressure tide. What does this means? Usually tides will be produced above the sea level. Right? So the low tide will have been present at the bottom. Right? So the incoming tide will be at the most bottom. So this is called as tidal barrage systems. Right? So next we'll see about what is ebb generation. Okay, ebb is nothing but a small falling of tide is called as ebb. So a tidal barrage ebb generation uses the energy of an outgoing falling tide, referred to as the ebb, as it returns back to the sea, making it an opposite of the previous flood tidal barrage. So basically, ebb generation is possible from an existing tide. So when you have a tide that is leaving the seashore, from that we'll be able to generate a small amount of energy that is called as ebb generation. At low tide, all the sluice and lock gates along the barrier are fully open, allowing the tidal basin to fill the up filling up the dam. And when the ocean or sea level feeding the basin reaches its highest point, the sluice gates will be closed. Okay, that is, we open the gate, we make the water to enter into the dam or reservoir, and then we close the gates. Okay. As the level of the ocean outside the reservoir drops on the outgoing tide, its low tide mark, the difference between the higher level of the entrapped water inside the tidal grade and the actual sea level outside exists. That is, we have high potential tide inside our dam, and we have a low potential tide outside the dam. So we have created a difference in the pressure. Now we will open the gate and we will let all the water to flow out. Okay. So this is happening in the sluice gates. So we have a difference in force of energy, which is used for running the turbine. So this rapid exit of water through the tunnels of the outgoing turbine pipe causes the turbines to spin at the faster speed. So this turbine will be coupled to a generator. So we'll see these operations now. So what's the difference between the previous case and this? Is that in the previous case we used the high head, okay, high head, and from which we converted to the low head. But from this case, we are going to store the energy first of all at high potential, and we are going to use this low head water. Okay, we are going to use the low head water, and this low head water will be passing through the turbine such that there will be a pressure difference created between this high pressure and low pressure outgoing tides. Okay, so because of this, there will be a flow of this turbine. So this turbine will start to rotate and will be creating a force. So what is the combination of both? That is called as two-way tidal barrage generation. So both the flood tidal barrage and the ebb tidal barrage installations are one-way tidal generation schemes. Okay, so either you can flow the water from low tide to high tide or high tide to low tide in both cases. So in order to increase the power generation and improve the efficiency, we are going to combine both. Okay, so by which we'll have two turbines, okay, double effect turbines, which will operate at low pressure as well as at a high pressure. So a two-way tidal barrage scheme uses the energy over parts of both the rising tide and the falling tide. So this will see the operation directly. So next topic is non-barrage tidal power system. That is, we do not have a dam. Okay, we are not going to have a dam. Directly, we are going to utilize this power that is existing in the dam into the operation, right? So that is called as a non-barrage tidal power system. So tidal steam generators are underwater tidal turbines which produce mechanical power by converting the kinetic energy from water current in a similar way to wind turbines which draw energy from the air currents. Okay? So tidal stream is a fast-flowing body of water created by tides. A turbine is a machine that takes energy from the flow of fluid. Okay? So in simple terms, what is tidal energy system is that we are not going to install any huge constructions that will stop the water. Right? So we are going to directly erect a wind turbine. Assume, for example, a wind turbine inside the center of the ocean. A wind turbine will be erected at the center of the ocean. Now this wind turbine will hit the blades and this will start to rotate the wind turbine. So obviously this turbine will start to rotate because of flow of water. And one point which you have to be very clear is we are not creating any artificial force. We are not going to increase or decrease the force. We are going to utilize whatever the force available inside the tide directly. So that is the main difference between barrage and non-barrage types of tidal system. So in non-barrage type, we do not have any walls, we do not have any dams, we do not have any reservoir. We will utilize the direct tides available, and that tides will be directly converting into mechanical energy in a turbine, and this will be coupled directly to the generator. So this is about the barrage and non-barrage type. So next we'll see about what is a tidal lagoon. Okay. So far we have seen about tidal systems in which the tidal turbine is placed in a location and generator will be placed in some other location in a remote area. Now in tidal lagoon, we have a power station directly in the sea. Okay, so we will take a small island at the center of the ocean, and in this island we will erect a power plant. Okay, and that I am calling that tidal lagoon. Okay, so this tidal lagoon will again operate very similar to that of a tidal barrage. Okay, so it will be operating at a tidal barrage by capturing a large volume of water behind a man-made structure which is then released to drive turbines. Okay. So unlike a tidal barrage, when a structure spans an entire river estuary in a straight line, a tidal lagoon encloses an area of coastline. So as the tide comes, that is the water, the flow of water, very high water flows. The turbine gates are open, which is used to control the flow of the turbine. Okay, so this creates a difference in the water level, and because of this, we have a lagoon inside the sea. Now, what is the basic definition of lagoon? Is that a lagoon is a very small structure inside the sea. Okay, that we are calling it as lagoon. So usually, very huge floods are called as lagoon. Okay, if at all the flood level is very high or the tidal level is very high, that we call as lagoon. Okay. So once the difference between water level is optimized, the wicket gates are open and the water rushes into the lagoon. Okay. Now, from which we are reconnecting the water to the turbines. So this is the diagram which will show you what are all the three types of tides. Basically, we have a flood tide. The flood tide will have a central lagoon. Okay, so this is called as turbine house. This turbine house is a artificial man-made construction at the center of the sea. Okay, so this turbine house is called as lagoon, and this is very small, very similar to a barrage. Okay, a barrage system which is placed at the center of the sea. Okay, now this will be having a very small amount of flow of water, and the head of the water will be high at one point and low at the other point. And when there is a difference in the head, you will obviously have a flow of water. This flow of water will be running a turbine. Okay, and obviously this turbine will be directly coupled to the generator in the rubber house, and you have a generating station here itself inside the sea itself. So from the sea we generate this power. Okay, so normally if you take some ships, If at all they do not have at the center of the sea, they use these lagoons to charge their batteries, all that from the center of the sea. Okay, this is one simple application of turbine house, right? Because if you see these ships, they cross the ocean for years. Okay, they travel for years, and at some point they used to see the power is very less in their particular system, and therefore all they want to recharge or if they want to store some energy, they go to this turbine house for storing the power. Now the next type is holding period. Okay, to know the holding period, so we create a small sluice gate and we stop the water. Right. So when we stop the water does not flow from one side to other side. So the head of the water will be same for both on the basin side as well as on the sea side. So the head will be same for both the side. So this period is called as the holding period. So during the holding period, the turbine house will not generate any power, okay? Because the pressure at both the sides is same. So we will not be able to generate power during the holding period. Now again during the generating during the F side, okay, that is when there is a low tide. We will utilize the low tide. So when the power is going outside and when the gate is opened suddenly, when the water is flowing out, then obviously using this low side will generate power. So this low tide is called as ebb tide, as I told you already. So by using this, if we generate power, that is called as generating on the ebb side. Next is wave energy. So up to this, we have seen about what is tidal energy, that is installing a wind turbine directly into a ocean, and this tides will be hitting the water. Next is wave energy. So first of all, understand wave is different and tide is different. Wave is not similar to a tide. Okay, wave energy is a different types of ocean energy. Tidal energy is a different types of ocean energy. So waves forms when wind blows over the surface of the open water. So waves are very similar to the top radiations that we talked in the electromagnetic spectrum. So they cannot be seen, but they carry some energy. Okay. So electromagnetic waves cannot be seen, but they carry some small amount of energy. Similarly here also, when you when the water is, when the wind is blowing towards the seashore, there will be production of waves. So ocean waves will be containing tremendous waves. So we should not talk about a small area. We should talk about some large areas. Okay, these large areas are called as oceans, and this oceans will have large amount of wind flow as well as it will have large amount of flow of water. So wave produces up and down, and this will have lots of floating devices. So these are called as wave capturing devices. And these waves are traveling across the ocean, and we have some high-tech devices to capture the natural movements of the ocean current. So basically, we go for wave capturing devices. So these are devices I will tell you in the next slide. What are all the various types of wave capturing devices? And the wave energy or wave power is essential for the production of waves. Okay. So when wind blows across the sea surface, it will transfer the energy to the waves, and they are powerful source of energy, and the energy output is measured by wave speed. Okay. So again here the speed of the turbine will be determined by the speed of the wave. So the wave speed will determine the mechanical output, and the mechanical output will determine the final electrical output from the system. So basically the strength of the wave is dependent upon wave height, wave speed, wavelength, and wave density, water density, right? So all this will determine what is the level of amount of waves that are produced in the particular ocean. So more stronger waves are capable of producing stronger power. The captured energy can be used for electrical power generation and also for pumping the water. So these are all the various types of wave profile devices. That wave profile devices is devices that are placed at the center of the sea to capture the waves. So we have some devices to capture the waves. So we see the operation and we see the types of those waves. So wave profile devices are a class of wave energy device which floats on the near of the sea surface. Okay. It moves in response to the shape of the incident wave, or for submersible devices moves up and down enter the influence of the variation. So to know the pressure. Okay. So this we might have seen somewhere in some places. You see, they'll be placing some small balls. okay, on the seashore of the ocean. These balls will normally float on the water. Okay. Now these balls, what they do, they capture the wave. Okay, they capture the wave and they focus at the one particular point. Okay. So if the physical size of wave profile device is very small and is very compared to the periodic length of the wave, these devices are called as point absorbers. Okay. The size of the device is very large or longer than the typical period of length, it is called as linear absorber. So for very small devices, it is called as point absorber. For very long devices, it's called as linear absorber. So to make the efficient use of the force, generally we go for some force reaction. And reaction points can be inertial masses such as heavy suspended ballast plates, seafloor anchors, or fixed dead weight or piles. Okay, as this. Okay. So these are all the three types of wave profile devices. Okay. So what is this? First of all, we have point absorbers. Point absorbers are very small units that capture energy. Okay, so we have some floating unit. So this floating unit will be floating on the shore of the water. So we have, this is the shore of the water. So waves will be produced at the shore of the water only, top of the water only. It will not be produced at the bottom. So this you can take as a difference also. Okay, what is the difference between wave and tide? Wave will be produced at the seashore, top of the water. Okay, whereas tides will be produced at the bottom of the water. Okay. Now these waves, when they are having a very small amount of power generation, we are calling it as point absorbers, right? And if these wave capturing devices have a very large area, a huge area, and they capture a very large amount of waves, then they are called as linear absorbers, right? So usually for these systems, we go for a support, okay, which is used for floating. Okay, that we called as buoy. Okay, the buoy is used for floating the device. Okay, normally if you see any object to float straightly in the water, there must be a supporting force. Okay, there must be a controlling force. That we are calling it as buoyancy force. Okay, that buoyancy force is created because of this buoy. Okay, and below this wave capturing device, we have a pump and we have a generator from which we generate the power. So usually to hold these devices, we fix this to the earth. That is by fixing the dead weight. Okay, this dead weight, that is like a very huge stone or any metal particle, can be used for holding this particular device. Okay, so this will be capturing the waves. These waves will be captured at the top, and this will be focused using this focal absorber. Okay, and what is linear absorber? Linear absorber will have a very large construction basically. This linear absorber will also be pinned to the ocean floor, and we have hydraulic joints to this also. Right? So this is about what are all various three types of ocean capturing devices. Okay. Next we'll see about what is oscillating water column. Oscillating water column is a popular shoreline wave energy device. It's normally positioned onto a rock, okay, onto a cliff here, which is placed at the sea. Okay. So they consistently float on the water and they're partially submerged on the water. Okay, they will convert the wave energy into air pressure basically. So all the wave capturing devices will basically convert these waves into air pressure. So the structure used to capture the waves energy can be a natural cave with a blowhole or a man-made chamber. Okay. So again, this is an artificial construction. This is used for capturing the wave energy and focusing the wave energy to one point. So either way the structure is built, it's perpendicular to the waves. So normally if you want to capture anything, you should have a force that is opposite to that of the wave. So that is called as perpendicular construction. Now this constant ebbing and flowing motion of the waves will trap the water and this will start to create an up and down motion of the water. Okay, so this is called as oscillating water column. So it's very simple. We have some flow of waves here. Okay, waves are placed at the shore of the water turbine. So this is the sea and this is the ocean floor. and these waves are made to hit an air column. Okay, so this air column is created because of this barrage. We have a wall chamber here, and this wall will create a barrage. Okay, now this you can understand by a very small feeling you get. Okay, see, most of the temples, okay, either if you have a church or if you see a Hindu temple or if you take a Muslim temple, they used to place a very huge construction at the entrance itself. Okay, in the entrance you used to see a very huge construction. Okay, in Tamil you call it as gobram. Okay, gobram is placed inside the entrance of the temple. If you take a church also, you can see some huge structure. Okay, a huge V-shaped structure. The mosque also we have the same construction. Now this construction is basically done because when you enter into the that particular place, the air flow at that particular area will be very high. Okay, if at all you go to that particular place, very close to that particular place, you can feel the air. Okay, your body temperature will become normal. Okay, and feel the air, and you'll have some stability of mind. Okay, so this is possible by constructing a huge wall, okay, by huge construction, which will block the wind, okay, block the wave basically. Okay, so similarly, we have some huge construction here also. Because of this, we have changing the position of the air. Okay, we are changing the position of the air, and this air is being made to hit the turbine. Okay, and this turbine will be starting to rotate based upon this column. Right? So this is a very small, very simple application. Also, we will not be able to generate very huge amount of power. We'll be able to generate only a very small amount of power by using this construction. Right? Next is a wave capture device. So wave capture device are many types. So one is a water topping wave power device. It's a shoreline device which is used for capturing the waves. In this, we are going to capture the wave energy and will be converted into potential energy. And the wave capture device or wave overtopping device elevates ocean waves. And the overtopping wave energy converter works in much the same way as an impoundment type hydroelectric dam. And the seawater is captured and impounded at a high level in these particular devices. Right? So what is a wave capture device? Again, here you see, we are going to construct a huge wall, okay, which I'm calling it as a ramp. Okay, I'm calling it as a ramp. That is, this ramp will obstruct the water, I mean obstruct the wind flow. It will change the direction of the wind flow, which will make to flow inside the reservoir. Okay, now inside the reservoir I have some small amount of water. Now this water is being created because of the low head, this side of water. So I have a small amount of water, which means I am going to create a high pressure in the water by using this wave energy. So because of this pressure, this turbine will start to rotate. Okay. TG means turbine and generator coupled. Okay. Turbine and generator coupling is called as TG, and this will start to rotate the machine, and this will start to generate power. Okay. And next we have ocean thermal energy conversion system. Okay. So this is the second topic of the unit, and we'll see about this in detail in the next class. I'll tell you about what is ocean thermal energy conversion systems. Okay? So far I have told you about what is tidal energy system, what is the wave energy system, and we have seen the types of tidal energy system. One is barrage and one is non-barrage. And coming on to wave energy system, I told you some operation about various types of wave capture devices which operates at various levels, that is to change the wind pressures. Okay? To change the wind pressures, these devices operate. And the next topic is the ocean thermal energy conversion systems. So in this topic, we'll see how to extract thermal energy from oceans. Okay. So how in geothermal energy there is heat energy below the earth. Okay, I told you there is heat energy below the earth, very close to 5,000 meters. Similarly, we have heat energy in the ocean also. Okay, so this heat energy is caused because of the temperature difference in the ocean. The hot and the cold temperature will basically create some heat production, right? So this is possible in ocean thermal energy conversion system. We'll see this operation, and we'll also see about what is the types of ocean thermal energy system. Basically, we have two types: one is open cycle and closed cycle. We will see all that in the next class, right? So for today, I have told you about what is the operation of wave energy system and tidal energy system. So from tomorrow onwards, we'll see about what is ocean thermal energy system, right?